All right, guys, and we're back for some more info on definite integrals. And just some things to remember, just quickly, when we talk about indefinite integrals, an indefinite integral is just another term for an antiderivative. So an indefinite integral doesn't have bounds. It just says, okay, if you take the antiderivative of x squared dx, you get x cubed over 3 plus c. When you use the phrase definite integral, a definite integral has bounds. It represents an area under a curve. So that's the difference between those two terms, right? So a definite integral is like integral 2 to 3 of x squared dx, trying to find the area under there. All right, so I want to give you some tips and tricks and show you how to start some new problems today. Here's one thing. Here's a tip. You can pull a constant out in front when you plug in. You can pull constants out when you plug in. So here's what I mean by this. Like, say you have to take the integral from -2 to -1 of 6x to the -2. So you can already see there are like a lot of minus signs in here. So when you integrate that, that's going to be 6. Okay, -2 plus 1 gives you -1, going from -2 to -1. But you could write this if you want as -6x to the -1 going from what am I doing? -2 to -1. Okay, -2 to -1. So you could like just leave the -6 in front and just say, okay, well I have, that's -6 times 1 over x. So I could leave the -6 in front, and then do 1 over a -1 minus 1 over a -2. And this is just helpful because sometimes these problems just have a lot of minus signs in them. So this is just -6 times -1 minus plus 1/2. So that's -6 times -1/2. So this problem actually turns out to just be +3. So just be careful with the minus signs. This idea of like taking a constant and leaving it in front, that turns out to be just a trick that I like to use. Okay, so let's talk about another type of problem that you're going to see today, and that's if you have a piecewise function, and you want to take a definite integral of a piecewise function. So suppose I tell you f of x equals x squared if your x is less than 2, and then 6 minus x if your x is greater than or equal to 2. And I'm going to ask you to find the integral 0 to 4 of f of x. Now, you might be tempted to just kind of integrate and then plug in something weird. What you need to do is split this up, because this is a function where, okay, graphically, and you don't need to know graphically what's going on, but it looks like a parabola for a little while, and then it switches into a line. So you need to break it up into 2 different integrals based on where that transition is. So because the function splits at x equals 2, you're going to split your integral at x equals 2 as well. Function splits at x equals 2. So you need to split up at x equals 2. Okay, so 2's in the middle of 0 and 4. So I'm going to split this up into integral 0 to 2 of f of x plus integral 2 to 4 of f of x. And now that I've split it up at 2, because that's where I have the transition from top to bottom, now that I've done that, I just need to plug in the appropriate function for each part. For each part. So as I go 0 to 2 of f of x, that is less than 2. So that's the top case. So that's saying that's 0 to 2 of x squared. And then 2 to 4, that's 6 minus x. That's 2 to 4 of 6 minus x. Okay, so I split it up into 2 cases because this is like less than 2. And then the other case is what you have if you have bigger than 2. So that's how you split it up into the 2 parts to use the different functions. Now you know how to do both of these integrals, right? This is x cubed over 3 going from 0 to 2. So that's 2 cubed is 8, so that's 8 cubed minus 0. Plus, okay, now let's do this one separately. So that's 6x minus x squared over 2 going from 2 to 4. So I'll plug in the 4 first, so that's 6 times 4. So 24 minus 4 squared over 2 is 8 minus, then when I plug in the 2, I have 12 minus 4 over 2 is 2. Okay, so let's see, that's 16 minus 10, so that's 6. So my answer here is 8/3 plus 6. Okay, and that's the key, is just break it up into those 2 parts, do the 2 parts separately, and then go ahead and add those results together. All right, now, same thing, right? Anytime you have a piecewise function, you do this, right? So if you have like let's say you have the function, it's 1 if your x values are greater than or equal to 1, and then 2x minus 1 if your x values are less than 1. If you have to do the integral from 0 to 3 of g, same thing. Just like split this up. I'm not going to do the whole problem, but I'm going to split it up. Okay, so I split it up in x equals 1. That's a transition. So as I go from 0 to 1, I'll integrate 2x minus 1. As I go from 1 to 3, I'll integrate 1. And I do those two integrals and I add them together. Okay, just one more definite integral I wanted you to take a look at today. Suppose we have the integral 0 to 2 of 3 to the x dx. I know it's been a little while since you've done that. So just a brief refresher on how to do these, right? If you have a function, say 3 to the x, the derivative of that function was 3 to the x times the natural log of 3, which is a constant. So what that meant is that if you were going in the other direction, if you were to integrate 3 to the x, instead of multiplying by that constant ln 3, you divide by the constant. Okay. And the same thing, right? If you have the integral at a to the x, that's just a to the x divided by the natural log of that base. Okay, so what that means is this is just 3 to the x over ln 3, going 0 to 2. So I'll just plug into kind of this whole thing. I guess you could pull out the ln 3 if you wanted, but this is just like 3 squared over ln 3 minus 3 to the 0 power over ln 3. So that just turns out to be 9 over ln 3 minus 1 over ln 3. Common denominator just turns into 8 over the natural log of 3. Okay, so that's how you approach these problems. That's definite integrals. Thanks for watching. I'll see you guys soon.